All right, we're going to continue our talk on organic chemistry. And for this section, what's important is we're going to be looking at different types of functional groups. And specifically, we're going to be looking at alcohols, thiols, ethers, aldehydes, and ketones. All right. Now for ethers, we're going to, so this first question says, draw the condensed structural formula or skeletal formula if cyclic for each of the following. All right. So for the first one, we have diethyl ether. So this is going to be an ether group with two ethyl groups on either side. Now an ether is going to have an oxygen, and on either side of the oxygen is going to be a hydrocarbon. So in this case, that happens to be diethyl. So we're going to have a CH2 and a CH3. This is an ethyl group. We can draw another one over here, CH2, and now a CH3. So this is diethyl ether because it's an oxygen with two ether groups on either side. Now down here what we have is we have cyclobutyl methyl ether. Once again, we're going to start with an oxygen. And it doesn't matter where the methyl group goes, as well as the cyclobutyl group. The cyclobutyl group could go here or the methyl group could go here. It doesn't matter. So here we are going to put our methyl group there. And here, now, butyl, remember we have meth, eth, prop, but, so it means it's going to have 4 carbons. And so we can draw this now as having 4 carbons. So here's carbon 1, 2, 3, 4. All right. Okay, for this next question, it says, are the following organic substances soluble, slightly soluble, or insoluble? Remember, soluble means they're going to be soluble in water. That's going to be the solvent. So these are going to be the solutes. And are these going to be soluble, slightly soluble, or insoluble in water? For this first one, what we have is we have an alcohol. So this functional group is going to be that of an alcohol. And it's a fairly short chain. All right, so this is going to be meth, eth, prop. This would be propanol and propanol. And this is going to be a fairly short chain fairly short chain alcohol. Most alcohols are going to be soluble in water so long as this portion of the alcohol is going to be very short. Once you get past 5 or 6 carbons, this starts to increasingly become less and less and less soluble in water. So this one is going to be soluble in water. All right. Now here what we have is you simply have a hydrocarbon. Anytime you have a hydrocarbon, these are going to be insoluble. And the reason being is that these are essentially non-polar. Remember, the electronegativity between the carbon and the hydrogen is going to be very, very, very small, such that this is very much a non-polar substance. Here you have this alcohol. There's a large difference in electronegativity between the oxygen and the hydrogen. So this becomes a fairly soluble compound because of that alcohol, right? This portion here is going to be insoluble, but so long as this chain is very short, this whole molecule will be soluble. Okay, now for this question, we are once again we're given the names of aldehydes and some ketones, all right? You know this is going to be an aldehyde because it says aldehyde in it. You also know this is going to be an aldehyde because we have the al at the end. So there's 2 ways to know what that's going to be an aldehyde. This is going to be a ketone because that's an one, and that's an one as well too, all right? Now the question says, draw the condensed structural formula for each of the following. So what we want to do is we're given a name. We want to come up with the structure, all right? Now the first thing here to recognize is you want to start off drawing the carbon backbone, right, to that. And that would be indicated here. So remember we have meth, eth, prop. So that means we're going to have 3 carbons. So I just start out with 3 carbons. 1, 2, 3, right? There's our 3 carbons. Okay. Now an aldehyde, remember, is going to be a carbonyl group. And then this carbon of the carbonyl group is going to be bonded to a hydrogen. So if we just simply put our hydrogens here, we'll come up with that structure. Now if we want to write it as a condensed, it then becomes CH3, that's this group here, CH2COH. You can either draw it that way, or sometimes you may actually see it written as where the H and the O are reversed, okay? Or if you want to, as far as I'm concerned, you can simply write it as that showing the aldehyde group, all right? Now down here what we have is we have 2,3-dichlorobutanol. Now we know that this is going to be an aldehyde because of the Al. Now I'm going to erase this, sorry. I kind of get, sort of erase this. We have a little bit more room to kind of work here. All right. But we know this is going to be an aldehyde because we have the Al suffix, the al suffix. So first of all, we're going to start with our carbon background. So we know that this is going to have 4 carbons. So we have 1, 2, 3, 4. All right. So we know we have that. There's going to be our 4 carbons. All right. Now we know that since this is going to be an aldehyde, we know that there's going to be a hydrogen and a double bonded to an oxygen. All right. And we know what this is going to be on the second carbon. All right, so we can call this we call this the 1 carbon because this is where our aldehyde is. This would be our second carbon. We know that there's going to be a chlorine there, and we know there's also going to be a chlorine here. So this is carbon 1, 2, 3, 4. And where I've left it blank is that's where, so you'd have is we're gonna have hydrogen. But I'll just draw them in real quick. You have a hydrogen here, hydrogen here, hydrogen here, hydrogen here. Excuse me, there is not going to be any hydrogens here because this carbon already has 4 bonds. So if we want to draw the condensed structure for this, this is going to be a CH3, all right? Now we have a carbon, Cl, hydrogen. Once again, we have a carbon, Cl, hydrogen, and then we have a carbon, double bond oxygen, hydrogen, all right? If you wanted to, though, you could simply put a hydrogen here and then draw the chlorines as such. And that I think is a little bit easier to see and understand. It communicates it to the reader a whole lot better. That's for that one. Now here we're going to be working with some ketones, right? Here we know they're ketones because we have the suffix -one, right? And we know that this is going to be a 5-membered carbon chain in that we have 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. There's 5 carbons. Now this 2 right here indicates that the carbonyl is going to be on the second carbon. So it doesn't matter whether we pick this carbon or that carbon. You can pick any one you want. I'm just going to be choosing this carbon to show this is where the ketone is. Remember, if this were a hydrogen, this would be an aldehyde. But because this is a carbon, because the carbon that is participating in the carbonyl is bonded to 2 carbons, that's what determines whether it's a ketone or an aldehyde. So since this is bonded to a carbon, this has to be a ketone. Right? So this is carbon 1, this is carbon 2, 3, 4, and then this is going to be our bromine as such here. All right? And so then the rest of this would simply be hydrogen. So this would be an H3, this would be an H, this would be an H, that would be an H. There would be no H here because this carbon already has 4 bonds, and this would be an H3 as such there. Now acetone is the most basic of all the ketones. So that's going to start with a carbonyl and then 2 methyl groups. All right, that's going to be acetone. That's the most simplest and basic of all the ketones. It's used sometimes in nail polish removers. It's one of the most prevalent solvents that's used in organic synthesis. A very important substance. Very volatile, actually very flammable. But this is going to end this portion of our of these organic function groups where we're talking about alcohols, esters, alcohol, ethers, thiols, aldehydes, and ketones. All right. Just a quick review. This is going to be an alcohol. That's going to be an alcohol. This would be a thiol. All right. An ether is going to be. We'll just draw this. Would be an R and an R. So that's going to be your ether. We know that this then is going to be now our aldehyde, and that's going to be our ketone. So those are the different functional groups we went over tonight. I didn't talk much about thiols. The naming is a little bit more different than it is for the alcohols. So don't worry too much about the naming of the thiols. But I want you to be able to recognize these different types of functional groups. All right? If you happen to have any questions, please let me know.